Welcome to Phantastic Physics. Today I'm going to show you a very exciting demonstration that I use as a physics teacher to teach students about electricity and about wiring electric circuits. So what I did was I went to my local hardware store and I bought 10 of these identical bathroom light fixtures. So this is something you might see over the sink in your bathroom. And I chose the 4 bulb fixtures because I know that there are actually 10 different ways to wire 4 bulbs together. So when you buy this at the store, you're typically getting them wired in one specific configuration, which I'll talk about soon. But there are actually 9 different ways to wire them. So I'm going to take this, or actually I already did, remove this bottom plate. And I went in and cut things and rewired things. And I made sure that all 10 of these fixtures were wired differently. So before I start explaining how that works, let's look at a schematic diagram. So a schematic diagram is a way to represent an electric circuit using this sort of symbol, right? Actually, multiple symbols. So the first symbol you're going to see in any schematic diagram is the voltage source. This is actually the symbol for a battery, and it's going to be one long line that's parallel to one short line. In this case, my voltage source is actually going to the wall outlet, so it's not a battery, and there is a separate symbol for an AC voltage source. AC stands for alternating current, which is the type of electricity you would get when you plug something into the wall. A battery is actually DC power, which stands for direct current. They're a little bit different, but for today's activity, I'm going to simplify and just use the battery symbol for my voltage source. And again, you're thinking the wall power, right? That's what's supplying the voltage to the circuit. Now the light bulbs are going to be modeled using this symbol in a schematic diagram. And this symbol is called a resistor symbol. So what is a resistor? A resistor is any element that you plug into your circuit that adds electrical resistance. In other words, these light bulbs, when I screw them in, are actually resisting the flow of electricity or the electric current flowing through the circuit. So an analogy would be like a beaver putting a bunch of wood and other materials in a river, and all of that stuff is obstructing the flow of water, so it's resisting the flow. And that's what these light bulbs are doing as well. They're resisting the flow of electricity. And so this schematic is showing a 3 light bulb setup, 1, 2, 3 different resistors, and the voltage source, so it's plugged into the wall. Now for today, all of our fixtures are actually 4 light bulb setups, so our circuits would have a voltage source and 4 light bulbs, or 4 resistor symbols. And this red arrow is just showing the flow of current, and we use the symbol I for current, so I stands for electric current. And that's the electricity that's flowing inside of all of these wires, okay? So what you see behind me are schematic diagrams for all 10 of the different ways to wire these 4 light bulbs together. And so you can see all of them are going to have a voltage source, which I labeled V, and I'm using the battery symbol, although we know it's not a battery, it's actually the wall. And so let's see, before we can understand all these different configurations, I think we need to first understand the difference between the 2 main types of circuits. So when you have all of your light bulbs or all of your resistors wired all in a row like this, so if it goes battery, light bulb, light bulb, light bulb, light bulb, back to battery, we call this a series circuit. So the word series, you can think of baseball, the World Series, game 1, game 2, game 3, game 4, they're all happening one after the other. That's the same way that these light bulbs are wired. So the wiring would go straight to the first bulb, to the second bulb, to the third bulb, to the fourth bulb, and back again, right? The other main way to wire an electrical circuit is called parallel. So this is a parallel circuit, and a parallel circuit just means that every resistor is wired on its own separate pathway. So rather than everything being in a single loop like this, you're going to have the voltage source go and actually start splitting up. So you'll have one light bulb on this path, there's going to be a split, another light bulb on a separate path, another split, a light bulb on a third path, and a final split of the 4th light bulb. All these wires will then come back together again. So we have a light bulb on 4 separate pathways versus 4 light bulbs on the same path. So we call this a series circuit, and this one is called a parallel circuit. 2 of my 10 fixtures represent those 2 basic configuration. And just to give you a heads up, when you buy these at the store, they're typically all wired in parallel, and there's a good reason for that, which I'll come back to. The other 8, so we have C, D, E, F, G, H, I, and J. All of these other configurations are a combination of series and parallel. So for example, if you look at J, here's the voltage source. We have one light bulb that's wired in series, but then it splits and we have three other light bulbs that are all wired parallel to each other. So this is a combination of series and parallel. Let's go back and look at C. So C has a split immediately. On one of the paths, we have a single light bulb. And then on the other path, we have three light bulbs in series. So this is three in series wired parallel to the fourth bulb. So, and if you looked at all of these, you could describe them similarly. They're all just various combinations of series and parallel. Okay, now that we know what a schematic diagram is, and we know what the symbols in a schematic diagram represent, and we know the difference between a series circuit and a parallel circuit, we're now ready to start the exercise. But actually, before we do that, there's one other thing we need to understand, and that is this. If you take your circuit and you unscrew one of the light bulbs, so if I, for example, came up to this one and I unscrewed this bulb, and now these three are in and this one is out, what that does when you unscrew a bulb, it's the same thing as removing the bulb. So imagine there's a hole here where one used to be. And in a series circuit like this, if you have a hole here, that means you do not have a complete path from the voltage source back to the voltage source again. And for a circuit to work, you do need a complete closed loop. So unscrewing a bulb will result in a hole, you have an incomplete loop, and therefore electric current cannot flow, and this entire circuit would shut off. So just by unscrewing bulb 1, I would expect bulbs 2, 3, and 4 to all go out together. And that's the main disadvantage of a series circuit, and why you typically wouldn't buy something like this at the store, wired in series, because it's very inconvenient to lose one bulb if one burnt out at home, and to suddenly lose all 4 bulbs at the same time. When you go to the store and you buy this 4-bulb fixture, you are likely to find it wired like this, in parallel. And that's because imagine unscrewing light bulb 1, you would have a hole here where bulb 1 is, and therefore you have an incomplete path along this path. However, you do not have a hole at bulb 2, 3, and 4, so imagine electric current is still able to flow through bulb 2 and back again. You still have a complete path through bulb 3 and back, and you still have a complete path through bulb 4. So at the end of the day, when you have a parallel circuit, losing one light bulb or unscrewing one bulb will not affect the other 3 because you only have one incomplete path and you still have 3 perfectly functional paths. So the main advantage of the parallel circuit is that you can unscrew one bulb and not affect the other 3. Okay, so now we're ready to start the exercise. What I'd like you to do at home is if you could pause the video and just look at this wall, and I want you to copy down all 10 of these schematic diagrams and label them A, B, C, D, E, F, G, H, I, and J. And then what I'm going to do in this video is show a very close-up view of me unscrewing each bulb for each of the stations. So the stations themselves are labeled 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And your job is, once you've drawn all of these schematics and labeled them with the letter, you're going to try to match each station with each letter. So for example, if I do station 1 first, when you see me do this in the video, you're going to try to decide which letter represents the schematic diagram that matches station 1 based on what happens when I unscrew the light bulbs. So yeah, take a moment to jot these down, and then once you have these, make sure you also have I and J, and I'll start the next part momentarily. Okay, so this is station number 1, and I've dimmed the lights a little bit so you can see the brightnesses of the bulbs a little bit better, and I'm going to go ahead and turn it on now. And you can see they're all on, but they're not super bright, so that might tell us something. I'm going to start by unscrewing bulb 1, and you can see that all the other bulbs went out. So now I will screw bulb 1 back in, and this time I'll unscrew bulb number 2. Once again, they all went out together. Now let's unscrew bulb 3. Once again, all bulbs went out. And finally, unscrewing bulb 4. also results in every single bulb going out. So now I want you to think about which letter this station matches up to. So this is station 1. Is it A, B, C, D, E, F, G, H, I, or J? So look at those 10 different schematics and see if you can match the correct one with this station. Okay, so are we ready for the answer? Station 1 is actually schematic diagram A. That was the one that was all in series, right? Because in a series circuit, unscrewing one bulb causes all other bulbs to go out. If you got this right, great job so far. Okay, so here we have station number 2. So let's go ahead and turn it on and brace yourself because this one is significantly brighter than the last one. Whoa! Okay, so we'll start with bulb 1. I'm going to unscrew that. And you can see that all of the other bulbs stayed on. Interesting. So now I'll put 1 back in. Let's unscrew bulb 2. This time all the other bulbs stayed on again. Now we'll unscrew bulb 3. Once again, they all stayed on. And then I'll unscrew bulb 4. And again, all the other bulbs stayed on. So take a moment to think about which of the letters A through J is the correct schematic diagram that matches this circuit. Okay, ready for the answer? So this one is actually B, right? So station number 2 is B. That was the schematic diagram where all 4 bulbs are in parallel. And we know these are in parallel because unscrewing one of these does not cause a disruption in the other the other 3 pathways. So they're all on 4 separate paths. If I unscrew one, the others are unaffected. Okay, so here's station number 3, and I'll go ahead and turn this on now. Careful, one of the bulbs is very bright. Okay, so this is a little bit harder to see, but you have a really, really bright bulb on the first bulb, and the other 3 are on. You can see a little bit of glow there in the filament, but they're significantly dimmer than bulb 1. So let's start with bulb 1. I'm going to go ahead and unscrew it. And what do we see happen? It looks like all of the other bulbs went out. So taking out bulb 1 puts out the other 3. Now let's put it back in. And let's go ahead and unscrew bulb 2. And what I notice is these ones got a little bit brighter, but more importantly, none of the other bulbs went out when I unscrewed bulb 2. Okay, let's put 2 back in. And now let's unscrew bulb 3. And so again, these 2 got a little bit brighter, but none of the other bulbs went out when I unscrewed bulb 3. And now finally bulb 4. So when I unscrew it, again, these ones do get a little bit brighter, but more importantly, none of the other bulbs go out when I unscrewed bulb 4. So take a minute and let's decide which of the 10 different schematic diagrams corresponds to station 3. Okay, ready for the answer? So the answer is, it's actually J. J is the schematic that matches this station. If you look up at station J, you can see it there on the whiteboard. Bulb 1 was the one that we unscrewed and it caused all the other bulbs to go out. And so that makes sense because it's in series with the other 3. And then notice that bulbs 2, 3, and 4, when I unscrewed those, because they're on their own separate pathway, they did not affect the other bulbs. Okay, so here we have station number 4. And so I'll go ahead and turn it on. And if you look closely, you're going to notice that bulbs 1 and 2 are on, but they're dimmer, and then bulbs 3 and 4 are much brighter. So let me start by unscrewing bulb number 1. And what I notice is that all 4 of the bulbs are out. So unscrewing this causes them all to go out. Now we're going to go ahead and unscrew bulb number 2. And the same thing happened. So all the other bulbs went out with it. Let's go ahead and screw 2 back in and unscrew bulb 3. And so this one is very tricky and it may be hard to see through the camera, so please take my word for it. I've been doing this for a while. Bulb 4 did stay on, and actually bulbs 1 and 2 are also on. They're just very, very, very dim, and they're hard to see because of the way this is configured, but I don't have time to get into that. So let's screw bulb 3 back in and unscrew bulb 4. And once again, 3 is obviously still on. But take my word for it when I say that bulbs 1 and 2 are also on. They're just so dim, they're almost imperceptible, right? So to review, unscrewing 1 and 2 caused everything to go out. Unscrewing 3, everything actually stayed on. And unscrewing 4, everything stayed on as well. Okay, so which schematic diagram does this represent? Let's take a moment to think. And so what's the answer? It is actually schematic D. So if you look up at D, D is the one where you have 2 bulbs in series, and those are the ones that if you unscrewed them, all the other bulbs went out. And then bulbs 3 and 4, because they're on their own parallel pathways, if you unscrewed 3, it doesn't affect the others, and if you unscrew 4, it also does not affect the others. Okay, so here we have station 5. Let's go ahead and turn it on. And what I notice is bulbs 1 and 2 are a little bit brighter and bulbs 3 and 4 are fairly dim in comparison. That might be a clue as to what is coming. Now I'm going to unscrew bulb 1 first, and it looks like all the other bulbs went out with it. When I unscrew bulb 2, all the other bulbs stayed on this time. When I unscrew bulb number 3, it looks like bulbs 1 and 2 stayed on, but bulb 4 actually goes out with 3. They go out together. And then finally, when I unscrew bulb number 4, again, bulb 3 goes out with it, but bulbs 1 and 2 stay on. Very interesting. So take a moment to think about this and see if you can decide which schematic diagram matches station number 5. So what's the answer? It actually turns out to be letter G. So if you look at G, G has 1 bulb that's in series with everything. So when you unscrew bulb 1, it makes sense that all of the others go out. And then we unscrewed the second bulb, bulb 2, and everything else stayed on because bulb 2 is on its own path. It does not affect the others. But then when we unscrewed bulb number 3, bulb 4 went out with it because they're on the same path, but everything else stayed on. And when we unscrewed bulb 4, bulb 3 also went out with it because again, they're on the same path, but bulbs 1 and 2 are on their own separate circuit, so they're unaffected. Okay, so here we have station number 6. And when I turn the switch on, all of them are on. They all seem to be of equal brightnesses. I'm going to go ahead and unscrew bulb 1, and it looks like bulb 2 went out with it, but bulbs 3 and 4 stayed on. Okay, unscrewing bulb 2. Again, bulb 1 and 2 went out together, but bulbs 3 and 4 are unaffected. They stayed on. Unscrewing bulb 3. This time 4 went out with it, but bulbs 1 and 2 stayed on. And finally, unscrewing bulb 4 causes 3 to go out with it again, but 1 and 2 stayed on this time. Very interesting. So take a moment to think about which of the schematics you think station 6 lines up with, and we'll see if we can agree on the answer. Okay, so what is the answer? It's actually letter H. So if you look at H, you're going to see that when bulb 1 was unscrewed, 2 went out with it because they're both in series on the same path, but bulbs 3 and 4, because they're on a separate path, they were unaffected. And likewise, when bulb 2 was unscrewed, 1 went out with it, 3 and 4 were unaffected. And then when we unscrewed bulb 3, bulb 4 went out with it, but bulbs 1 and 2 stayed on. And when we unscrewed bulb 4, bulb 3 also went out because it's in series together, but bulbs 1 and 2 stayed on because they're on their own separate path. All right, so here we have station number 7. Let's go ahead and turn it on. And what I notice is bulb 1 is significantly brighter, but bulbs 2, 3, and 4 are definitely on. They're just much dimmer. When I unscrew bulb number 1, it looks like 2, 3, and 4 are all still on. Now when I unscrew bulb number 2, bulbs 3 and 4 both go out with it. So bulbs 1 is the only one that stayed on. And then when I unscrew bulb 3, the same thing happens. So bulbs 2 and 4 go out with it. Bulb 1 is the only one still on. And then when I unscrew bulb number 4, again, 2 and 3 go out with it, but 1 is the only bulb still on. So based on what we just observed here, which schematic diagram do you think corresponds with station number 7? What do we think? Okay, ready for the answer? it looks like it is C. So if you look at the schematic for C, we have one bulb that's on its own parallel path. So when I unscrewed bulb 1, it did not affect the other paths. So 2, 3, and 4 stayed on. And when I unscrewed bulb 2, because 3 and 4 are in series with it, they go out with it. But bulb 1 is unaffected because it's on its same path, its own path. And then again, when I unscrewed bulbs 3 or 4, it caused everything else to go out in that pathway, never affecting bulb 1. So C is the correct answer. Okay, so here we have station number 8. I'm going to go ahead and turn it on. And what I notice is I've got a couple of pretty bright bulbs and a couple of slightly dimmer bulbs. I'm going to unscrew the first bulb here, and I notice that everything else stayed on. Unscrewing the second bulb, again, everything else stayed on. Unscrewing bulb 3, I noticed that bulb 4 goes out with it, but bulbs 1 and 2 are still on. And then unscrewing bulb 4, again, 3 goes out with it, but bulbs 1 and 2 are still on. So based on what we've seen, can you identify which schematic diagram corresponds to station number 8? Okay, so what's the answer? Station 8 is actually schematic F. So if you look at F on the whiteboard, remember when we unscrewed 1, it did not affect any of the other bulbs. They all stayed on, and that's because 1 is on its own path. It does not affect the other paths. Same thing happened with bulb 2. When we unscrew it, it does not affect the other perfectly good and complete paths. So bulbs 1, 3, and 4 stay on. But when we unscrewed bulb 3, because 4 is in series on the same path, 4 also goes out with it, leaving 1 and 2 on. And likewise, when we unscrewed 4, 3 goes out with it, but 1 and 2 stay on. Okay, so here's station 9. Let's go ahead and turn it on. And so all the bulbs are on right now. I'm going to go ahead and unscrew bulb 1. And it does look like bulb 2 got brighter and 3 and 4 got a little bit dimmer here, but they're all still on. So unscrewing bulb 1 did not cause any of them to go out. Okay, let's unscrew bulb number 2 now. Again, bulb 1 got brighter. Looks like 3 and 4 got a little bit dimmer, but none of them went out. So when I unscrewed bulb 2, everything else stayed on. Unscrewing bulb 3 now. Again, same thing happened, but this time 4 got brighter, and it looks like these got a little bit dimmer, but everything else stayed on. So when I unscrewed bulb 3, nothing went out. And then when I unscrew bulb number 4, 3 gets brighter, these look like they get a little dimmer, but again, everything stayed on. This one is the only one that went out. So which one is this? Let's take a moment and think about it and see if you can come up with the answer at home. Okay, so what is the answer? It turns out that this is actually station E. So if you look at E, it's a very interesting setup where you have 2 that are in parallel, and that set of 2 is actually in series with another set of 2 that are in parallel. So in other words, 1 and 2 are in parallel, 3 and 4 are in parallel, and the set of 1 and 2 are in series with the set of 3 and 4. And so that's why when 1 was unscrewed, everything else stayed on because the current could still go through bulb 2 and still pass through the other bulbs. And when 2 was unscrewed, everything else stayed on as well because it can still pass through bulb 1 and then go through 3 and 4. And then likewise, unscrewing 3, everything stayed on because it can still go through 1 and 2 and then go down through the 4 path. And then finally, unscrewing bulb 4, you could still have current go through 1 and 2 and pass through bulb 3. So E is the correct answer. And last but not least, we have station 10. So let's go ahead and turn this one on. And I see, different bulbs, different brightnesses. I'm going to unscrew bulb 1, and it looks like everything else stayed on. Okay. If I unscrew 2, it looks like 3 and 4 actually went out with it, but bulb 1 stayed on. And then if I unscrew bulb 3, it looks like 3 is the only bulb that's out. Everything else stayed on this time. And then finally, unscrewing bulb 4, again, everything else stays on. 4 is the only one that's out. So based on what we just saw here, what is the correct answer? Which schematic diagram matches what we saw here? And it turns out the answer is I. And actually, using process of elimination, we would have known this. It's the only one remaining. But if you look at I, remember, unscrewing bulb 1 did not affect the other 3 bulbs because the current could still go up there, pass through bulb 2, go through 3 and 4, and so those would still work. Unscrewing bulb 2, remember bulbs 3 and 4 went out with it because current could still go through bulb 1. There's a nice loop there, but if there's a hole where 2 is, current will never be able to get to where 3 and 4 are. And then when I unscrewed bulb 3, every bulb also stayed on because a hole at location 3 does not affect the circuit through bulb 1, and it won't stop current from going through bulb 2 and 4 and getting back to the battery. And then finally, unscrewing bulb 4, same result. It does not affect bulb 1, 2, and 3 because those are still perfectly valid pathways. Thank you for watching Phantastic Physics. Please like this video and subscribe to our channel if you want to see more interesting physics content. Goodbye for now, and remember, it's a fantastic universe out there, so stay curious.